Most of the students are getting into the 700 math score range and they can't improve. They just stuck there, whatever they do. And the reason is second module hard questions. So in this video, I've picked 5 of the hardest SAT math questions that show up in the second module as the last questions. And if you really want to practice the hard questions that show up in the second module, then I highly recommend you to check out the 100 SAT predictions, which I've picked the 100 most repeated questions that show up, the hard questions that show up in the second module. Like Michelle, who went over these questions and she got 12 of the exact same ones on her exam and she got a 1470. Link in the description. But before moving to the questions, did you know that statistically students have a way better SAT score if they're subscribed to this channel? So if you haven't yet, then smash the subscribe button now because I come up with free content to help you hack the SAT. Now let's move on to question number 1. Alright, question 1, the expression 6x to the 4th power plus 17x squared plus 7 can be rewritten as this, where a, b are positive integers, or as this, where c and d are positive non-integers. What is the value of a plus c? Okay, so this expression is the same as this expression, right? So what I can do, I can distribute this and set it equal to this one because they are the same. It can be written as this one, so they are the same. And then we can match the variables here to the expressions, to the coefficients here, right? So let's do that. I'm going to first distribute this one. So it's going to give us, we're going to distribute this way. It's going to give us 6x to the 4th power plus 3bx squared plus 2ax squared plus ab. And this is the same. So here I can also factor out x squared. So I can write 3b plus 2ax squared. If we factor out x squared, because x squared is the same in both of them. So we're going to write 3b plus 2a times x squared. Now, this is the same as this 6x to the 4th power plus 17x squared plus 7. So if we match them, we're going to see that 7 is ab, right? The coefficient of x squared is 17, so 3b plus 2a is 17, and here they are the same. So here this term says that these are going to be the same. So if you had 12, for example, here, but 6 here, then you have to divide all of these by 2, then set them equal to each other. Okay, this is important. Now, let's keep going. So these are equal. Let's write these equations. I have 3b plus 2a equals 17, and ab equals 7. So this is a system of equations, right? I have 2 variables, 2 equations. So we're going to plug this, all the system of equations, we're going to solve this on Desmos. But before plugging into Desmos, rather than b and a, we have to plug as x and y. So I'm going to name these x and y. So I'm going to say, let's say a is x and b is y, and we're gonna plug it this way. Okay, so let's do that right now. So we have 3y plus 2x equals 17, and we have xy equals 7. So we have this graph right now. We're looking for the intersection points. So we have 2 intersections. That means we have 2 solutions for the system of equation, this point and this point. If we look at the question, so we don't need to do the same thing to this expression because these 2 expressions are exactly same, only the c and d are different, right? So that's why this system of equation has 2 solutions, because it said a, b are positive integers, so we have positive integer solutions, and c, d are positive non-integers, and we have positive non-integer solutions, right? So these are a, b, that's what we're looking for. A and B. Now, which one is A, which one is B? We said A is X. So A is in the X coordinate. So X coordinate is 7. That is our A. So I'm going to write it down here. So we'll say we have A equals 7. B is 1, right? And in the non-integer ones, one of them is C, one of them is D, but we didn't write this equation in terms of C and D, and we don't know which one is X coordinate is C or Y coordinate is C. Which one is C? So look at this expression. We have A, B here, C, D here. C is sitting at the same position as A. 3x squared A, 3x squared plus c. So c is also going to be counted as x coordinate because a was the x coordinate. So x coordinate is 1.5 and that's what we need. C, so c is 1.5. C equals 1.5. So we are looking for, go back to question, always in the hard questions. After finding the solution, go back to the question, see what we were looking for. We're looking for a plus c. So 7 plus 1.5, 8.5 is the answer for this question. Guys, if you have other friends who are studying for the SAT and they need help in the second module hard questions, then you can share this video with them as well. So why not to get a target score together, right? Question number 2 says the function f of n equals 7 times this gives each term of a sequence as a function of the term's position n in the sequence, where n is a whole number. The value of the term in position 14 is p% more than the value of term in position 10. What is the value of p? Okay, so this function gives us the value of a term in nth position, and the question says the value of the term in position 14 is p% more. This is very important. It doesn't say p% of, it says p% more than the value of the term in position 10 because they are different. So we're looking for the difference of percent change, right? We're looking for the percent change here because it says more than or less than. How much this is more than this. So look for the percent change in terms of percent. So the formula for percent change was the percent change is the difference between the numbers divided by the initial value times 100, right? That is the difference, the difference change, the percent change of the two terms. So we have position 14 and we have position 10. So what we can do, we can find these values by plugging 14 into the function and then plugging 10 into the function and then finding the difference, dividing by the initial value and times 100. That's what we can do. We have another way, a second way that is faster, but let's first do the first way so you get the idea how it works, and then we can do the second way as well. So we're going to use Desmos to do the first way. So I'm going to plug the position 14 into the function. So 7 times 20.44 to the power of 14 divided by 4. This is the number, right? Now we have 7 times, I'm going for the position number 10 to the power of 10 over, to the power of 10 over 4. Yeah. And that is the number for the position 10. Now, we're looking for the difference between these. So on Blue Book, on the exam, you can't copy this number. And also, I don't recommend you to copy this number because sometimes Desmos rounds up these numbers and it just doesn't show you the exact correct number. And when you copy that or when you type that number that you see and you find the differences, then you might have an error and then you do some calculations on that and then you come up with the wrong solution. So what we recommend you to do, rather than copying this whole thing, just have this, right? Use the expression itself. Don't copy the number. So if you want to find the difference between these two numbers, I'm going to find the difference between these two expressions. So I'm going to basically take this and put it here, okay? So I'm going to say negative 7 times 20.44 to the power of 10 over 4, right? Now this is the difference between numbers, okay? The correct way, the most correct one. So this is the difference. We found the difference. Now you have to divide this whole thing by the initial value, by the position 10, the number at position 10. So I'm going to divide the whole thing by 7 times 20.44 to the power of 10 over 4. So again, make sure that when you're typing these, make sure that you type them correctly. You don't do any errors, like maybe like 2.044 or something like that. Don't do any of those errors. Make sure, like, check it 2-3 times that you don't have those errors. And then we're going to multiply this by 100 and we get the answer. 1944 is choice C, correct answer. Most students miss this question by choice D, 2044, because they find the term in position 14 is p% of the value of the term in position 10. They find the percent of rather than how much percent more, right? So if I give you an example, for example, let's say we have number example here. Let's say we have number 3, and I say the next number is double this, so 6. So let's say this is x, this is y, right? So here, if y is 2 times x, then how much percent more it is? If it's 2 times x, it's 200% of x, right? But how much more? It's 100% more. So what we did, the percent of minus 100, or the percent, let's say we say this is 2 times that. So I do this minus 1, give me 1, then times 100. So it's 100% more, right? That's the difference between percent of and percent of and percent more. How much percent more, how much percent less, right? That's very important. The second way that we can do this question is, this is an exponential function here, right? And the rate of change, because we're looking for the change, depends on this this rate of change here. This is the rate of change, right? This is initial value, this is the rate of change in exponential functions. That is, to this exponent has an exponent here. So I'm looking for only this number, and the difference between this term and this term is 4 units, right? So I'm gonna plug 4 here. It's gonna give us 20.44 to the power of 4 over 4, which is gonna give us 20.44, right? This gives us how much this gives us the number position, the term in position 14 is how much times the number in position 10, right? So this gives us how much times, or how much percent of, if you multiply this by 100. So because we're looking for the more than, we want to do as we did here. We want to do 20.44 minus 1, 19.44. Now we found the change, how much it changed. Then when you multiply this by 100, you get the percent, right? We found it in percent. So again, choice C is the correct answer for this question. Question 3, in the given quadratic function, a and c are constants. The graph of y equals f of x is a parabola that has a vertex at edge k, and k is negative, and we have this, which of the following must be true. Alright, so before solving this question, please pause the video and do it yourself, and let me know in the comments if you were able to solve the question or not. If you solved the question, just let me know. If you know other ways to solve the question, then let me know as well. So now pause the video, do it yourself, and then check the answer. In this question, you get these kind of questions so many times in the last question, as the last question in second module, that has this magical word, must be true, right? So this is different than is true. Must be true means it's always true, okay? All right, now we're gonna discuss that later, but let's see how we can solve this question. So we have this, and let's try to graph this question. So if I have a graph here, we're gonna graph a parabola. We have -5 and we have 7, right? So the question says the f of -5 is equal to f of 7. That means they have the same y coordinate. Those 2 points have the same y coordinates. That doesn't mean that the -5 and 7 are the x-intercepts. That doesn't mean that. We can have these points, we can have these points that are in the same y coordinate, okay? So that means our vertex of this parabola is at the middle point of these -5 and 7, right? So how can we find the middle point of -5 and 7? You add them up and divide it by 2. So -5 plus 7, 2 divided by 2, 1. So the vertex line is 1. This is our vertex line right here, okay? So that is 1, and we also have k that we don't know where is it. So now this is our vertex line. Our vertex can be here or here, anywhere on this point, because parabola is symmetric to the vertex line, to the symmetrical line, and this is our vertex, let's say. And then always we're gonna have like the same points at -5 and 7, okay? So now what we can do, I don't know if the point is here or the point is here, but the question said this is our vertex, h, k are constants, and k is negative. So the y-coordinate of the vertex is negative. So that means the vertex can't be here because y-coordinate will be positive. So vertex should be below the x-axis, right? So let's say vertex is here. And this parabola has a negative a, so a is negative. That means the parabola is downward. If it was positive, it would be upward. So then this will be how the parabola looks like. It goes downward and the vertex is here. This is how the parabola is going to look like. Right now, let's look at the choices. We have C and we have B. So with this symmetrical line here, we know that this is the symmetrical line, and we know that this line we can find that line by using the formula. You tell me. Negative b over 2a, right? Awesome. So negative b over 2a is the formula that we can find that symmetrical line, right? And we know that that line is already 1. Okay, so I can set that negative b over 2a equals 1 and solve for b. Negative b equals 2a, and a is negative 2, as we know here, right? As we know here. So we're going to put negative 2 into a. It's going to give us negative b equals negative 4, and b equals 4. Awesome. So we found b. And here the question says b is larger than or equal to 3. So here's the question for you. You're going to ask this. B is equal to 4. Is 4 always larger than 3? Because the question says must be true, means always should be true. So is 4 always larger than 3? Yes, it is. 4 is always larger than 3, right? So this is correct. Okay. Now, let's check the C. It says C should be less than negative 1. So C is here. C is we know that based on the parabola, we know that the C is the y-intercept of this graph, right? It's here. And 100% C is negative number, because the vertex is below the x-axis and the parabola goes downward. So C is going to be a negative number, but we don't know if it's less than negative 1 or not. If here was negative 1, let's say if here is negative 1, then yeah, this vertex, the y-intercept would be less than negative 1. But if here is negative 1, then the y-intercept would be larger than negative 1, right? So it will be different. It will be larger than. So what we know is that C is always less than negative. It's always negative, but we don't know if it's less than negative 1 or not. So is this always true? Well, this can be true and it cannot be true, right? So that's why that is wrong, because we are looking for which one must be true, always true. So that one is wrong. The second one is correct. Choice B is the correct answer for this question. All right, next question, we have the expression this can be rewritten as this one, where b is a constant, that h, j, k are integer constants. Which of the following must be an integer? Okay, so this looks like the first question, right? We have some expression can be rewritten as this format. So we're going to do the same. We're going to distribute this and then match the variables with the terms here. Okay, so let's go ahead. Let's distribute this first. So we're going to have hx squared plus hjx minus kx minus kj. Here x, so I can factor that. We're going to have hj minus kx. hj minus kx. Awesome. This is the same as bx squared minus 13x plus 22, right? So now if you match them up, we're gonna see that h is equal to b, then hj minus k is equal to negative 13. Okay, hj minus k equals negative 13, and negative kj is equal to 22. Equal to 22. So we have 3 equations. Now in the first question, what we did after doing this and matching them up, we had 2 equations and 2 variables. We made a system of equations, we put it into decimals and solved for it. But here we can't do that. Why? Because we have 1, 2, 3, 4 variables, but we have 3 equations. If you want to solve a system of equations, you have to have the same number of the equations as the number of the variables. So if we have 4 variables, we need 4 equations. So right now, We have 4 variables with 3 equations, so that means we're not going to do the Desmos one, right? So we have to do it in a different way. So I'm going to check the choices to see if I can do anything with that, because it says h, j, k are integer constants, right? So k minus 3 over h. Can I make anything with these? Can I make k minus 13 using one of these equations? It looks like this, right? We can move this negative k into the right side, and it will be hj equals k minus 13, right? K minus 13. So I can say k minus 13 is hj. So I can put hj here, right? And then this h and this h cancels out, and we're going to have j. So this choice A is equal to j. And j is an integer. So which of the following must be an integer? Again, here we have the keyword must be, by the way. So that means it's always an integer, okay? It's always an integer. So this is always an integer. It's always equal to j, and it's always an integer. So choice A is the correct answer. But let's check the choice B, C, D. If let's say choice A wasn't the answer, and we had to check the other choices, how we would use this must be here, okay? So let's say I have now 13 over B. B is equal to h, so I can put h into B. It's gonna be 13 over h. The reason that I did that is because the question said B is a constant. We don't know if it's an integer or a constant or non-integer, but h is an integer, right? Now, of course, we could say h is an integer, so it's equal to B, so B is an integer. We can also do it this way. We say 13 over an integer. Now, if h is 13, it's an integer, and if it is 13, then this would be 13 over 13 equals 1, and we would get an integer, right? But it can also be something else, right? It can be, let's say, 2, then it won't be an integer. So it depends on what is h. So it's not always an integer. It's not always an integer. It goes back to this part, okay? So this is out. Negative j over 22. I see that here. So what we can do, 22 is negative kj, so let's just put that here. Let's say negative j over, so 22 is negative kj. So negatives cancel out, j's cancel out, and what I get is 1 over k. K is an integer, so 1 over k, if k is 1, it will be 1 over 1, we get 1, it's an integer. But if k is a different number, it won't be an integer, so it's not always an integer. This is also out. The same is going to be for this one, k over 22. Again, let's say 22 is negative kj, so let's put that there, k over negative kj, so k and k cancel out, and we get negative 1 over j, and it's the same concept as this one. Negative 1 over j, j is an integer, it can be an integer, it cannot be an integer, so it depends on what is j. It's not always an integer, so this is also out. Choice A was always an integer, that's why that's the correct choice. All right, so if you've made up to here this question, then type the GOAT in the comments, because first I want to see how many of you have made up to here, and second, let's confuse everybody who hasn't watched this part. All right, we have the last question. We have a long equation here, and it says in the given equation p is a positive constant. The product of the solutions to the equation is this. What is the value of p? So the product of the solutions means if we plug this into Desmos and see the x-intercepts, and then the x-intercepts are our solutions, and then multiply them, that's going to be the product of the solutions, right? But here we have a problem because we have a p here, and Desmos doesn't know what is p. So if we plug this into Desmos, we won't be able to see the graph, and we don't know what is p. So we won't see those x-intercepts, right? So we have to find this in a different way. So we don't know how to find the solutions of this whole equation like this, but this equation is in the factored form. And the solutions, we know that the solutions, the zeros of the factors are the zeros of the whole equation. The reason is because if this becomes 0, it's going to multiply it by this, and the whole thing is going to be 0. That's why the zeros of these factors are the zeros of the whole equation. So we're looking for the zeros of these factors one by one, and that's why the equation already gave us the equation in the factored form. So what makes this equation, this expression 0 here? So I'm gonna set it 3x minus 7p equals 0 and solve for x. X is gonna be 7p divided by 3, right? So the 0 of this factor is 7p over 3. Let's go for this one. Now, if you want to find the solutions of this, is a quadratic function. This is a quadratic form. We can use the quadratic formula to find the zeros of this, the solutions of this, and then multiply them at the end to find the product, right? Because at the end we're gonna multiply this solution of this one, then this one, and the solution of this, and then multiply all of them, set it equal to this, because it says the product of all these solutions is equal to this, right? So that's what we're looking to do. But at the end we're gonna multiply these, right? So rather than finding the solutions of this individually, which is gonna take a lot of time using the quadratic formula, we can directly go for the product of the solutions, right? We know that in quadratic formula, so let's remember those two formulas. In the quadratic equation, the product of the solutions, we can find them by C over A. The sum of the solutions is negative B over A. Yes. So these are very important. You can get the same question on your test with sum of the solutions. So it says there's an equation in the factor form. In the given equation, P is positive constants. The product, it says the sum of the solutions to the equation is something. Find the value of P. The same thing with the sum of the solutions. So you also have to know this one, okay? So now we're looking for the product. So I'm going to do C over A, right? So this is C, this is A. So C over A is going to be negative 4P over 5. Negative 4P over 5. So that is the product of the solutions to this one. Okay. Now for this one, this is x to the third power. We don't know how to find the solutions of this, but that's why this function, this one, is already in full format. There is no variable here. So that means I can put this into Desmos and see the x-intercepts, right? So let's just go ahead and do that to find the solutions for this. X cubed plus 3x squared minus 16x minus 48. Let's zoom out. All right, so you see the x-intercepts. One is here, the other one is here, and the other one is here. So if you want to find this, so we're just going to multiply these, right? So 4 times negative 3 times negative 4 is going to give us, even that, I'm going to do it on Desmos. Just avoid mental math in the exam so you don't do any silly mistakes. Negative 4 times negative 3 times 4. Again, I'm going to check if I plug the numbers correct, okay? So negative 4, negative 3, 4. Negative 4, negative 3, 4. It gives us 48. So the product of the solutions is 48 for this one. Now, if you multiply these, 7p over 3 times negative 4p over 5 times 48 should be equal to negative 560 over 9. And now we just need to solve this equation for p, find the value of p, right? All the equations we can solve it using Desmos, one variable equation. So I'm going to put this into Desmos, but rather than p, I'm going to put x, right? So Desmos can solve for x. 7x over 3 times negative 4x over 5 times 48 equals negative 560 divided by 9. So we have two lines. That means we have two solutions. One is 0.833. The other one is negative 0.833. So which one should I go with? We go back to the question always after finding the solution. We go back to the question and read the question again and see what we're looking for. In the given equation, p is a positive constant. Okay, so I'm looking for a positive constant. So I'm going to put the 0.833. So now you might be asking, we can't, so Desmos is basically rounding this, right? The answer is 0.8 and this 3 is just repeat infinitely, right? So we can't put all those 3's into the box here. We have only 5 characters to put, so put it in a way that you put the most precise, in the most precise and most accurate way format, right? So rather than putting 0.833. That would be also correct, but I would put 0.8333. Now we have 5 characters. 1, 2, 3, 4, 5. This is the most correct way that you can plug there. Now you can also put this in the fraction format. Okay, so if you get if you solve this equation manually on the paper, then you're gonna get the fraction format. You can also put that way. That would be also correct. So you can put either the fraction in the fraction format, or you can put it this way as the most precise answer for the question number 5, and that's it. Awesome. So you're done with the 5 hard questions. Please let me know what is your target score in the comments below. I want to see what are you aiming for, and also if you want to practice more, do more hard questions, you can check down the SAT predictions. Link is in the description. It's the 100 most repeated questions on SAT. We've spent a lot of time on gathering these questions and making for you, organizing them, taking video explanations from the past SATs and the patterns that you can see the student results who was gone through this course. And I wish you good luck on your test. Let's get a target score.